Welcome everybody. My name is Marcin Dryjanski and I'm the CEO and co-founder of Rimedo Labs, a spin-off of the Poznań University of Technology in Poland. And we are a research and consulting company focusing on wireless communications, OpenRAN, 5G and beyond. And as you can see, my talk today is on 5G, private networks and OpenRAN, where I'd like to touch upon those aspects to show how they fit together in the future of wireless systems. And a few words about myself. I've been involved in 5G development since 2012, where I've been a work package leader in 5G Now project. Later, I was working as a RAN architecture consultant at Huawei R&D office, and I'm also a co-author of a book entitled From LTE to LTE Advanced Pro and 5G, published by Artech House. And I did my PhD on radio resource management for LTE and 5G. So that's a short story about myself, and now about the actual session today. So there will be 5 sections, so 5 main sections here, where we are going to start with a little bit of background, speaking of mobile wireless systems evolution. I'm not going to go into the details on that, but to have a little bit of a background and touching certain points that I would like to expand later on, because they will influence the other aspects as well. So we'll speak about 5G itself, a little bit more into specifics, not about the overview, but some aspects I would like to touch upon, because that will lead then to why do we have ORAN at this point in time. And then the second portion, or a second piece of puzzle, or second puzzle in that session is about private mobile networks. Again, we are going to speak about what it is, what are the different options, where is it useful, and why it's needed. And then finally, we'll speak about the topic that is on everybody's mouth currently or recently, ORAN, and we're not going to get a very deep dive into that. That, as Russell said, will be a separate webinar, I would say, where we could speak on different topics, of course. But today I'm going to sketch a little bit of history and the reasons and the transition from the typical radio access network to OpenRAN. So let's treat that as an overview session on those topics, where they could be treated as puzzles that then we'll try to make them a single picture afterwards. And of course, at the end, we'll have a little bit of summary of what we spoke during the session. I will try to keep it to as close to 50 minutes as possible, but it might get a little bit longer, especially with those questions around. And here is also my request, or my kind request to Russell. Whenever there will be a question, I will not see the answer. So please just then unmute your phone and unmute your mic, and then basically say what are the answers. So let's start without further ado with the background. And that picture is pretty much, I would say that everybody knows already, but I would like to point here on 2 aspects. First one is that starting with 1G, where we didn't have a digital voice or a digital communication that was an analog, that then transits to the second generation, where we had pretty much the same service with a digital voice version, and then we moved to adding internet access, of course, simplifying everything, because in GPRS we already had the internet access. Then going to 4G, which was all about internet access and getting high-speed videos and all that. And then getting to 5G, where everything is about everything being connected to the IP transmission and expanding towards different businesses and towards various, let's say, vertical markets, instead of just focusing on giving access to the people over the typical internet services. The important point is that in the first two generations, we had one network for voice. Then we had in 3G what was the sort of transition point where we had one core network for voice, another one for IP, and then we moved everything to IP. And since then, we only have the IP and internet access for all the different services. So the focus is now rather to try to address the different needs for the totally different service types and totally different requirements, as we will see later on over the years. And of course, getting all the bigger numbers for transmission speeds and getting lower latency are just 2 points. The important aspect here is that we are moving towards the software-defined networks, not only in the core network, but also in the radio, as we will see later on. Now, another view on that is that starting with the upper layer, we had a single or simple, maybe not a simple is a good word, but a single system design for a specific service that we had there. So we had the analog voice, then digital voice, then IP connectivity, then mobile broadband. And that was a single focus for the particular system. And starting with LTE Advanced Pro and transiting to the second row here, we are moving towards a complicated or more complex system than ever before, because we firstly have several different radio interfaces connected in some ways, like satellite or Wi-Fi integrated or NB-IoT or LTE integrated to 5G. And secondly, instead of focusing on a single type of service, let's say, we are expanding towards different versions, which makes the first time in the history where we have, let's say, a service mix starting from an IP, but going into different directions in terms of requirements and needs. And then the second point I want to make here is that there are even and odd generations, and the even generations happen. The odd generation happened to be the first time when the new service is coming. So we had 1G with voice, we have 3G, let's say roughly, with IP connectivity, and 5G with a service set. Whereas the even generations go to the direction of extending that service, making it better, where second generation was a terrific success with mobile voice, and then 4G was a great success in terms of the mobile broadband access. Now, I'm not saying 5G is not going to be a great success, but it will certainly, it's starting an era where we have different services on those triangle provided by ITU, but also basically expanding towards different directions in terms of requirements and the service needs. So most probably we will go into, already there are things happening here and there around 6G, but that will for sure be extending that service mix to other directions, making the system even more complex, because that's the whole reason why I'm speaking about all that. Now, the first introduction of getting a little bit complex in terms of system was LTE Advanced Pro, where along the way, starting from LTE, which was focusing actually on a single service that was the mobile broadband, but then adding more and more features along the 7 releases of LTE, brought it a little bit complicated animal, where we had focus on towards the IoT with NB-IoT and LTM, licensing options and unlicensed spectrum access, getting more resources to basically serve more users or giving better capacity, adding other accesses like Wi-Fi, or also focusing on those very requiring or very, I would say, difficult in terms of requirements, services like V2X or D2D, basically then having that niche and needing specific features in the system to allow that. With 5G, we pretty much can see all of those features bringing together natively in a system, which actually makes it very complex. So this is where, with LTE, we added everything on top of a single system. With 5G, we are having that animal already there, adding LTE as well, and then tweaking it here and there. for those different services. Now, so let's now go to 5G. Again, not a lot of details here, but a few points. Firstly, the standards roadmap. We started 5G with release 14 back in 2017 with the freezing of that release, where the requirements have been defined for 5G system. Then the overall 5G as defined or as required by ITU in terms of ITU IMT 2020 was defined. It was split into two releases. Release 15 with 5G phase 1, covering most immediate needs and focusing on EMBB and initial ultra reliable low latency communications, and frequencies already the millimeter wave frequencies, but the lower part. And then going to release 16, that was frozen last year. Actually, it is a year from now, where it was frozen to support that the system supports all the ITU requirements to be called a 5G system, expanding it towards the V2X and machine type communications and so on. And then currently, 3GPP is working on release 17 that is expanding and improving 5G for all the features that were there already to be there in release 16, but wasn't covered, and also the new ones like NTA, so non-terrestrial access, higher frequency bands, and integrated access backhaul. So that is a set expanding to the basic 5G system. And as of now, we already have on the agenda the 3GPP release 18 that is supposed to be around the end of standardized at the end of 2023. And we already have the marking point having that information that this will be a really expansion of the 5G called 5G Advanced that was released last month. And here it's not yet defined. They are going to specify that around December this year on the technical specification groups around December. But the most important point is that there will be 3 different areas. The first one is enhanced mobile broadband. That will be one focus. Another one, everything else, so non-enhanced mobile broadband, pretty much covering all the IoT or Industry 4.0 aspects. And then the third group will be cross-functional, so features related to both to allow them to cooperate and so on. So you already might see that 5G is already out there. 5G is being defined, and then we are moving towards the expansion towards another, let's say, a breaking point, which will be 5G Advanced, similar to what we had in LTE, where we had LTE and LTE Advanced later on. In general, 5G, as already mentioned, is tailoring or is targeting a set of services. I'm not going to speak about free services because that's a little bit too bold to say. I think it's more about 3 groups or specifying that there are different groups that require specific that have specific requirements, focusing on different aspects like machine type communications or massive machine type communications, focusing on connection density, ultra reliable low latency on the other edge, or latency and mobility, and enhanced mobile broadband having huge capacity and huge data rates, focusing on delivering that to the end users and providing new services. The important point is that there is a 5G system that should support all of that. Of course, not all of that at the same time, at least not in all the places. But what is important is that it needs to cover those aspects in some ways. And those ways are the different technological elements like millimeter wave, massive MIMO, flexible numerology, unlicensed spectrum, V2X, and so on, integrating LTE and NR, and going also to softwarization and automation with SON and SDN, and also then, as we'll speak on the OpenRAN and softwarization of the radio access network. The important point is, again, we have a huge system that needs to support specific elements, needs to be configured the way that it supports certain requirements or fulfills certain requirements, and that it needs to adapt. And that's the main importance, or the most important point for me in 5G system. It needs to adapt. There are thousands different parameters. It needs to fulfill certain requirements, so we need to somehow adjust those, and that's the complexity that 5G brings, together with spectrum bands. So already, as we know, it's the first time, again, in the history where we have millimeter waves in the mobile communication systems. Of course, it's not supporting mobility as of its primary use case, but it is supporting millimeter wave for certain use cases. And we also, as before, had an unlicensed LTE, and then LTE, and then shared spectrum with CBRS and licensed shared access features. With 5G, we bring all of that natively already from the start, from the scratch to the system. In terms of 5G architecture, also not going into much details, the important 2 points here is that we totally are splitting user plane from control plane. So we have a user plane function down to where the packets are going, towards the data network or DN, and the control plane allowing actually to provide the SDN concept, or software-defined networking, where the whole control is up and can be basically evolving separately from the user plane and from the RAN. And the second point is that that's service-based architecture, so as we can see, there are, of course, there is a version of that picture where we have the interfaces between each of the points here, but on that particular picture, and the focus of 5G recently is that we are using the REST API and HTTP2 to support a service-based architecture, where each of that element up there, the UDM, PCF, NRF, whatever they mean at this point, it's not really important for that particular point, but they are specific microservices that can be deployed together, and they can be exchanged separately. And what we need to do is basically use REST API, and so that they can communicate with each other with the server client basis. So that's the point here. And now to the 5G complexity, I'd like to make some points here. The first one is that the complexity comes with naming, with all the features. In terms of what we have on that picture is the radio access network below, composed of the base stations and controllers, and the core network on top. And below, we already have 2 different names. So for radio interface, we call it new radio, whereas the RAN, or radio access network, is called NG RAN, not new RAN. So there are 2 different names for those. Partly that's the reason. The reason for that is that it covers both the new radio and LTE. So LTE is also part of NG RAN, of course, supporting the access to the core network. But the core network is not called the new core. It's not called the NG core. It's called 5G core. So again, a different naming for that. Now, even further, if we speak to the different groups in 3GPP standardization, the interface between those can be marked or named differently depending on who you are speaking with. In the RAN groups, it's called NGU for the user plane and NGC for the control plane, whereas if you speak to the system architecture guys, that's called N2 and N3 interface. So that might lead to some misunderstandings in some points. Where if we compare that to LTE, it's pretty simple, where everything is just E of the previous system. So E enhanced UTRAN, that's the radio access network. E UTRA is the radio interface, evolved packet core, and evolved packet system, where here we have all those different namings for the different aspects. Going even further, there is a certain very important feature in 5G network, that's dual connectivity, where we have the two base stations connected together, where one is master and secondary, and the second one is a secondary node, giving or providing more capacity to the user, where the user can be connected to both. And now, without going into the details of all that, that's a single feature, but in 5G, it's called differently depending on the configuration. So whether we are connected to 5G core or to the EPC, whether that's an LTE master and 5G secondary node or the other version, instead of just calling that dual connectivity and having those options, each of that has a different name. So that's pretty much that again may lead to some misunderstanding in some points, and you need to memorize all those different aspects, having not only a single abbreviation, dual connectivity or DC, to memorize, but all those different things. And then finally, in terms of complexity, if we take a look on the layer 1 or physical layer parameters that are standardized, so that's a comparison that you can look versus the LTE. So for non-standalone version of 5G, there were like around 600 layer 1 parameters to cover within radio resource configuration control specifications, or the RLC protocol, to configure, to be able to configure the lower layer, compared to 80 parameters for LTE release 88, which shows the biggest difference. It's like 7 times more parameters. And now, if we ask yourself how many of those parameters will be used and configured, if you are to do that manually, it's pretty much not possible, or most of them will just not be used or used with the default settings. And that goes into the direction that we need intelligence, that we need the possibility to automate the configuration and adaptation to certain use cases. And then finally, now actually it's the first question for you. How do we call that one? Pretty much everybody of you are correct. And that's the important point, that's the complexity point here, because everything seems, we can call it differently depending on what generation do we have and what setting do we have. In 1G, that was a base station. In 2G, that was a base and transceiver station, to reflect a little bit more of what it actually does. And because we have a transceiver and then we had a controller. In 3G, because we moved to the node nomenclature, that's a node B. And then in 4G, again mentioned in the previous slide, that's we added E to everything. So that's evolved node B. And then in 5G, pretty much you're correct, that's a G node B. So that's not a new node B. That's not NR or next generation node B. That's not 5G node B. It's a G node B. So again, it's not consistent with the other nomenclature that we saw on the previous slide, but it's even worse. Depending on what's the configuration, we might have a different answers. So again, going to the previous slide where we had dual connectivity options, depending on if that's a base station, the LTE base station connected to 5G core, or if it's 5G base station connected to 5G core, or 5G base station connected to EPC, or whatever. In all those settings, they are called differently. And then even further, if we go to the split option of the CU and DU, that's a G node B DU. But then if you go to the other option, then you have also possibility to lower layer split. And that's then the lower layer split G node B DU. And I saw also there was an answer that's an RU. And of course, that's also correct if we are speaking about the ORAN architecture. So the point here is that 5G is complicated. And in addition to the complexity, right, technological complexity and a set of features that we have, the nomenclature is also bringing that complexity to another level, making it a little bit harder to actually operate in terms of if you have a feature and then that's only for EN G node B or for NG E node B. That might be confusing, at least. Now, in terms of the 5G complexity on the architecture point, we already saw that. But if we compare 3G, where we had the controller called RNC, then in EUTRA, they decided to move the controller to the base station, actually. And with 5G, it's again split out, which also shows that we are moving back and forth with the concept depending on what we learn from the previous system. What is important here, though, is that in 5G, we have the full split between the control plane and user plane that was getting actually an evolution. So from SGSN and GGSN that covered both control plane and user plane, then the MME taken out, adding the some of the control plane out of the user plane path, and then with AMM, F, and SMF and all the other elements shown in the previous picture, that's actually totally separated, even with the IP address allocation. And the final aspect is that when we bring all those different elements, all those different features, and 5G with LTE, with the D2D and dual connectivity and license assisted access and Wi-Fi and LTE and relaying and higher frequencies and lower frequencies and 3,000 different services to support, there is a huge challenge for radio resource management for within that heterogeneous network. There is a need for automation. There is a need of self-organizing networks, and there is a need for artificial intelligence, at least in some cases, to support this huge heterogeneous network, let's say heterogeneity and the service heterogeneity. So that's one point that you should remember when getting into further elaboration, specifically in the ORAN aspect. And that will close the first part. Now to the second point, the private mobile networks. So private mobile networks are pretty much dedicated for enterprises. So why are they showing up? Firstly, because we have technology. So, of course, there are different ways of doing that, but in different countries, there is a dynamic shared spectrum access possibility. Like in the US, there is a CBRS. In some European countries like Germany, there are local licenses for private networks, actually. There is a technology called the private mobile networks in 3GPP already, and then possibility to use smaller networks for dedicated purposes, and there are multi-operator schemes defined as well. On the other end, there is a regulation where there are possible exclusive spectrum uses, or we might use licensed assisted access with Wi-Fi like spectrum and so on. And then there are business possibilities with micro operators, private mobile networks, and then verticals that would like to have or might utilize finally the mobile networks for their use, like, I don't know, for factory automation, because it's not all for 5G. It's not that you can assign 5G to private mobile networks. 4G is as good as well in some cases. In some cases, it's needed to have more advanced features that 5G brings, especially for those low latency services. So what a private mobile network is, it's an optimized and tailored LTE or 5G network with the core network and with the radio interface. In some cases, it's a little bit smaller set of features, but it's dedicated for an enterprise that is independently managed and that provides, and why not Wi-Fi? The difference between Wi-Fi and this one is it provides carrier-grade security and privacy. And it might be owned by an MNO, that's one option. Another one by the enterprise itself and managed. And then the other option is that's the venue owner's network that provided for certain application for the enterprises. There are, of course, as in all cases, there are different options how we can do that. The first one is a standalone, where there is a dedicated network where the core network and RAN is at the enterprise premises. There is one called hosted by MNO, where the MNO hosts the network and then just provides the service, but dedicated to the enterprise. There is a RAN sharing when the core network for the users and services for the enterprise is hosted there, but we use the resources of an MNO and the base stations. And there is, of course, the one that is provided by 5G, that is an MNO slice. So basically a slice that is dedicated to the enterprise application for a specific service, where the enterprise uses the MNO's network, but pays for the service. Whereas now the difference between all those is where the user credentials, where the service information is, where are the SIM cards, or if they are USIM cards, and also who's the RAN network and also who's the license. Now, those different options might be then discussed for the specific needs, and we will have some questions to pose before you decide which option is good for you later on. But one point I want to mention here is that within release 16 of 5G or 3GPP, there was a specific feature called NonPublic Network, which is a name for a private network with two different options: a standalone network that is operated by an NPN operator, meaning basically it's not relying on MNO, and it has the users basically has subscriptions to those instead of having subscriptions to the mobile network operator. And the public network integrated non-public network, again, a very complicated name, where this is the private network deployed with an MNO support, and it uses a dedicated spectrum or a slice of the network. And in that case, the users have subscription to the closed access group, and that closed access group is a typical UE that is allowed to use the services for that particular enterprise. Now, the difference between those two, without getting a little bit or without getting deep into the differences, is that on one hand, the standalone NPN, the maintenance is at either the IT department of the enterprise, or there is an integrator that takes that. It can use its own spectrum, or let's say a small spectrum for that particular location. It's in the responsibility of the enterprise for UE, SIM subscription, security, and it does not provide roaming. In that case, it's higher CapEx because you own the network, but lower OpEx because you don't pay for that to the MNO. You use it by yourself. Of course, it depends on the numbers, but typically it might be the lower value. On the other hand, when there is a public network integrated NPN, so the one managed by the MNO, it's the MNO spectrum, it's the MNOs managed, it's the responsibility for MNO to work on security and subscriptions and so on. It provides the regular roaming, so you can connect your phone to that network. Going out from your work, you connect to the MNO network, the regular network, and then it's lower CapEx because you don't invest in the infrastructure, but then you have to pay for renting the spectrum, renting the network, and paying for the management. So before you decide between those different options, and there are of course sub options between them, there are little differences between them. But basically, the important questions you need to ask yourself is who owns the spectrum, the network assets, and the core network. Do you want to have a licensed or shared, or do you need that, or you can live with unlicensed spectrum? That, of course, depends on the use case. Then, what are the requirements or capabilities, and what needs to be dedicated? Is it enough that you have a shared base station, or do you need to have your own, because you need all the resources, and you cannot allow, in terms of slicing, for example, that there is some kind of sharing of the resources between you and other networks, and what's the privacy requirements from your side, and so on. Then the other question is, do you need it for a single local premise or multiple premises over the wide area? So do you have a single factory, you need it there, or maybe you have multiple factories and you need to connect them, or you need, I don't know, a wide area because your private network is for, I don't know, providing access to the vehicles on highways. Now, my second question to you is, what do you think are the other questions that you might ask yourself before you could decide? And so in that, what do you think are important aspects that the private mobile networks could address if you have actually a factory? So what's important to take into account, in your opinion?
So you're asking what are the design parameters or considerations for setting up a private mobile network, yeah?
Yes.
Any feedback from the students? What do you think about when you want to set up a private network?
Yes, that's exactly a very good point and not mentioned here. Ashkai has, what are the types of services that the private mobile networks has to serve? That's actually the most important one.
Use cases,
because, yeah, or services, because that then leads to what do you need to realize that.
Yeah, so you can see now a lot of good answers now,
Yes.
Latency, the number of users, security considerations, lots of good answers there. Everybody, it seems like everybody's paying attention.
Yeah, that's good. Yeah, security is very important, and privacy here. So do you need actually your database of the users at your premise, or is it okay for you to have it at the MNO part or MNO core network? Yeah, and of course, then another one that is also a good point, which is how big is your network? Not only if it's a single local premise, but if it's 1,000 base stations, or is it 2 base stations, that is enough. And that might impact the decision of how you would like to realize that, because that actually goes down to the price.
Yeah, that's one of the benefits, I think, of the service-based architecture in 5G is the scalability, both up and down. You can go to very small private networks, or you can scale up to huge networks, nationwide networks. So it's a real benefit of 5G is that scalability.
Yeah. Yes. And then, of course, you might have all of that in a cloud, so like in AWS, instead of at your MNO premises. Okay, thanks for all the questions. So that will close the second part of our webinar, and the third one, final, from RAN to ORAN transition. So the question again is, shall we go beyond 5G? We already have the question in the answer. So will we have 6G or whatever next G do we have? So one option would be that 5G evolves in an umbrella of technologies where there are new features to be added over time. And in that case, we will not need a 6G in terms of technology. Maybe that's for 6G to answer. If we go with 6G with a feature set or a construction where we will be able to add those new features and new technologies for the specific use cases, that will actually end the G thing. But for now on, we have the next Gs every 10 years, and for 6G it's already started. The research projects and the discussions in the different forums. Now that we know that there will be a next G, how to approach that and where to start. So as of now, we have a single types of networks, closed interfaces, single vendors, and so on, hardware-based RAN. And we are moving to the open networking in RAN with hybrid networks, open interfaces, and many different vendors, new vendors, and open initiatives like XRAN, VRAN, and then that brought to the ORAN and telecom infra project and other aspects as well, or other initiatives as well. We have the possibility to virtualize RAN, and we have the possibility to share network in terms, because again, we have the software-based networking, which allows that to happen. Now, if we look at the history of hardware software, then in the 80s and 90s, there was a consumer softwareization because there was a drop of compute power cost for consumers. And then we went to the Windows and to Linux and distributed applications. Then in 2000 and 2010s, there was an enterprise softwareization where the compute power cost dropped for enterprises. With cloud computing and as Linux-based SDN and so on. And now what happens is actually the same happens for the telecom softwareization. So there is a drop of computer power cost for the computation it needs for the telecom solutions. And then we are going towards the standardized RAN hardware and the telecom softwareization. Now, if we look about those different something RAN, then what is the CRAN is a centralized BB processing, basically, where we have proprietary hardware for all the aspects for RRU or remote radio unit, and the PBU, which is basement unit. If we go to the virtualization of that, then we use a BBU on a COT server, but still with proprietary and virtualized software. And with ORAN, we actually go towards opening interfaces, programmability, openness, adding artificial intelligence, and we put the COTS-based hardware pretty much everywhere with the virtualized software that might be virtual, that might be and will be proprietary, of course, but the open interfaces allow to cooperate between the different entities and allow to distribute the software part among different vendors. So all in all, that we go from the traditional RAN single white box to the open RAN, where we split those different aspects. They are split in a standardized manner with a CU, so control unit, distributed unit, and remote unit, and the RIC, which is RAN Intelligent Controller. We'll speak about that in a second. The important part is that it's basically a disaggregation of the network towards opening, enlarging vendor ecosystem. It's about opening interfaces, and because of that, that allows different vendors for each of those points within OpenRAN, within the RAN architecture. That allows the coupling hardware from software, and it brings the intelligent management, because it's from one side, it's always fun for the researchers to work on the new technologies and apply AI everywhere. But on the other hand, looking at the complexity that the 5G together with LTE has, it's pretty much impossible then to move forward with those different use cases without adding intelligence to the network and making it being automated instead of manual configuration. Now, if we look at those aspects from 3GPP basis, not again going to the details, as this is an overview session, the important point is that we have the central unit covering the SDAP and PDCP protocol into the user plane. Or actually, that's a typo here. That should be CUCP and that's CUUP. But in the control plane, we have radio resource control. Here we have PDCP, so handling the IP packets. Then we have the radio processing handled at the distributed unit. That's the radio link control, MAC, and physical layer. That's where the scheduler goes. That's where the resource allocation on the smaller TTI basis operates. And then we have the lower physical layer and RF processing. That's the remote unit. So at the central unit, there are non-real-time functions like connection management, radio bearer configuration, handover, and cell selection configuration and actions. Then we have distributed unit with the scheduling and all the physical layer, upper physical layer processing like interference coordination, segmentation, concatenation, error correction, multiplexing of the packets. And then the remote unit with the real-time physical functions like IFFT, FFT, MIMO beamforming, and radio frontend. So that's actually the split onto those three different elements. So central unit with the non-real-time functions or near real-time functions. Then we have real-time functions at the distributed unit and remote unit. Now, with that, we are going to the ORAN as such. So we'll start speaking or having this architecture in mind with CU, DU, and RU, how that fits and what was brought with the OpenRAN. So we have 3GPP standards that defines those elements. Then we have ORAN Alliance. That's the main point that defines and specifies the architecture, specifies use cases, specifies functionalities, interfaces that allows the disaggregation for the different elements. And then going further, we have the open source platforms bringing or building the software based on the ORAN specifications. And those are then mapped or checked or verified with the use cases that are defined by the operators under the umbrella of telecom infra project. So from the left side, we have reference designs, we have architecture definition, we have feature designs. Then we have the exemplar platforms that are the OpenRAN software. And then we have use cases development that will then lead to, let's say, feedback loop. I believe that goes actually the other way around as well. So whenever a new use case is provided, then checked if that works and what is needed to be added. For example, a new parameter that goes back to the ORAN Alliance standardization and then goes back to the update of the software. And there are, of course, additional new entities like OpenRAN Policy Coalition to promote those policies among regulators and governments to promote and speed up the ORAN concept adoption. In terms of the timeline history, I would not say all start in 2016, but that part related to the concept that it's now time to do that is where the Telecom Infra Project was formed and XRAN Forum was formed, and then some OpenRAN, the first trials were provided. And then from the XRAN Forum and CRAN Alliance, the ORAN Alliance was formed in February 2018. And then the whole thing pretty much kicked off towards the SCF. There was a Rakuten in the meantime who provided the first virtualized network with multiple vendors, and then the ORAN Alliance partnership with TIP last year. So that means a little bit getting into the point where we have those bodies working together, which brings everybody's attention. Then the OpenRAN Policy Coalition, and then the next sets of OpenRAN Alliance specifications in March and in June. So there are it's more and more clear how that looks like. Also, they have the so-called virtual exhibition at ORAN, where they provide the demos showcased at Mobile World Congress, and that's as of now, there is 36 new demos showcased that were showcased this year in Barcelona. Now, if we go back for a second on the base station split, where we saw those different elements on the left side, and on the right side there is an ORAN Alliance architecture. I'm not going to go into the details of that's a separate topic of itself for another webinar or a session, but the important point is that we have this protocol stack where there is a CU, there is a DU and radio unit, and the important part is the RAN intelligent controller that is also exposed via the open E2 interface, where all the radio resource management or slower radio resource management functions are sitting. And getting again a little bit back to what we showed just in the beginning in the 3GPP context, this is how it looks in the ORAN context. So a little bit merging those three different entities. We have ORU, O meaning that it's OpenRAN Alliance specified remote unit, distributed unit, and OCU, CP, and CUUP. They are all called E2 nodes because they are all connected to the RAN intelligent controller over E2 interface. And that RAN intelligent controller is split into two parts: the slower adaptation loop, control loop, non-real-time RIC, that is more of an orchestration entity and machine learning sits there. And then a little bit faster, near real-time RAN intelligent controller, where, for example, handover optimization, traffic steering, interference optimization, or interference management sits and allows to adapt those resources separately. And then again, there is a scheduler that is actual real-time radio resource management that's not exposed over E2, that's sitting in the OTU software part. In terms of working groups, just a quick shot. There are 10 working groups in ORAN Alliance. There is a working group 1, which is focusing on identifying use cases and overall architecture. Then there are 2 working groups for non-real-time and near real-time RIC, focusing on the interfaces, but also on the use cases and radio resource management functions sitting there. There are 2 working groups focusing on the interfaces themselves, the open interfaces within RAN, like F1, E1, and front haul. There are 3 working groups focusing on actually bringing that platform where the software sits, so virtualization, modularization, hardware, software reference design. And then there is an open transport network working group focusing on front haul, mid haul, and back haul. And then there is an OAM framework focus group and the working group number 10. There is a new one as well that's not called a working group, but a special focus group for the security, as the security is an important part, especially if we have those different blocks not provided by the single vendor. Again, there is an ORAN virtual exhibition where you can see the different demos by the different companies, to see videos and presentations and demos from the latest events like Mobile World Congress Barcelona or in Shanghai. Already mentioned, there is a software community, a collaboration between ORAN Alliance and Linux Foundation, when they have different projects providing the open source versions of ODU, central unit, near real-time control, non-real-time control, and actually an open source XApps, so the applications that provide different radio resource management functions, and SMO or service and management orchestration for providing the orchestration platform and non-real-time RIC. And then the final point for today are the use cases. So what actually is addressed by those different entities and working groups in the ORAN Alliance? It is split into phase 1, phase 2, based on priorities. And you can see from the ORAN Alliance specifications and requirements for those different use cases in terms of, let's say, RIC and automation and all those aspects. There are 5 use cases on phase 1 with a little bit more specified items, and then the second point, which are phase 2, called phase 2. In the left-hand side, you can see traffic steering, quality of service, and quality of experience optimization, massive MIMO, and white box hardware. On the right-hand side, a little bit more challenging aspects like slicing and also V2X and drone communication, focusing on those specific aspects that they're challenging and they need specific treatment in terms of, for example, management of those. And then the latest development is actually the technical priority document provided as a memorandum of understanding by the operators, where they specified what is important for them, taking into account the ORAN and ORAN Alliance architecture, where you might see there are different priority levels and priority types, and this is provided by DT, Orange, Telefonica, TIM, and Vodafone. Released last month. You can download the whole file from this link. It's actually on the ORAN web page, and it's split into several different use cases part. It pretty much, I think it's hundreds of them for each of that. That's an Excel file. When you can look at those, that's an example cut off from this, only from the RIC use cases, and only a portion of that. It's really a huge list. And you can see, compared to the ORAN Alliance use cases, there is a traffic steering, of course, there is quality of experience optimization, and all those that were defined in the ORAN Alliance as phase 1, where you have all the different let's say details here, like what are the involved elements, what is the specification, where we can find the description of that use case, and the description with a little bit more detailed. Whereas in the specification itself, it's a very detailed definition and actually policies that you can control that. And then, of course, you have the priority level as marked in the previous page. You can see that all those are priority. 0 means high priority and important for them to address. So I really encourage you, if you're interested in this topic, to go and download that document. It's a huge file with the different elements, whether you are focusing on remote unit or RAN or RIC or use cases. And then the final point, what are the pros and cons of ORAN? So on the green part, it's avoiding vendor lock-in. You have different vendors. It enables faster innovation because you can focus on a specific aspect because of the open interfaces and the possibility to add algorithms in terms of microservice-based X apps. It reduces CapEx, provides the quick time to market, allows more companies to participate in this. And new services and applications being provided in a faster way. On the red part, it's new software hardware requirements. You need to adapt to that. There is an interoperability issue. So how you make sure that everything works with everything. Integration. So who is the one to integrate those? It's a complex automation because there are different entities. They might be from a single vendor or multiple vendors. There is the security aspect to it that is an important thing to address currently, and the price actually. So it promises to reduce CapEx, but whether for the overall total cost of ownership, if the OpEx is the one that we will also reduce, or will the part with interoperability, integration, and maintaining those networks will be cheaper? That's actually a question, and that's actually a challenge to make sure that we don't exchange a big boxes from a single vendor to multiple smaller pieces, but we will pay the price for bringing those together and making them operate. So that was the final point. There are, of course, resources that I would recommend you to read around that. And let me close that with a summary of what we spoke today. So the mobile systems evolved from one size fits all, 1G to 4G, to the complex mechanism with multiple use cases, multiple technology elements, and multiple services that they need to support. 5G brings that complexity and all the different aspects, including nomenclature and targeting the different industries and private mobile networks. On the other end is tailored 4G, 5G solutions for specific applications, where we can actually use the 5G complexity and just cut off a certain portion of it for our requirement. And then the third piece of that is OpenRAN, that brings the flexibility, disaggregation, decreases vendor lock-in, but then on the other end introduces integration costs. There are different entities or standardization bodies or ecosystem bodies that are now trying to merge, including ORAN Alliance, TIP, OpenRAN Coalition, ONF, to contribute to the overall movement. And the final point is that the ORAN Alliance is the one to standardize the architecture, interfaces, and building blocks. So concluding with these three different elements, we have 5G that brings technology to realize certain vertical requirements and provide the possibility to use it in different applications. There is private mobile networks that enable to create smaller networks for realizing those for specific vertical and businesses. And there is OpenRAN that makes this be a little bit flexible, bring intelligence to the network, and hopefully driving down the cost of the overall network. And with that, I would like to thank you for your attention. And if there are any questions, I would be happy to answer them. One more comment. If you're interested, you can check out our blog and download the white paper